Dear students, so today we will find that how we can find the code for entropy calculation. So let's suppose we have this data. This data is given to you, and we are supposed to find the entropy or Gini index. So first I will find entropy for you in this video, and then later video I will find Gini index for you. And how can we find it? So let's give me this file name as a entropy calculation uh, for array means like data in a row. So I have almost how many elements I have, like 1, 2, 3 and 4. So you can be given different, like data, and you can compute over here. So how did I find this code? So since, like management P students, they are not like used to for the code, so they can take help of ChatGPT or Google Bart, right? So they can write that what is the code uh, for example, I wrote what you call it, the input as like code for entropy in the Python. Okay, there is a special name for this one when you write this one. One is called response, and this is called, like the input we have over here. So when I write the code for entropy in Python, so I got multiple codes. You can choose any of the code over here. There are some, like shorter codes if you are using the SciPy library. So this code is okay. This code is a bit shorter. We can try this as well, but for that you must have these libraries. Okay, so now let me try this first, this code, and I put over here and see that how it works, and we will analyze it, that what are the different things. So here in this one, what we do, it we import the NumPy library, and we what we call it, we just name as a alias as np. Okay, and then we have, like function. So def is means like definition for the function. So we like have a one function which is called entropy, and here this one function calculates, like the entropy of these numbers. So in this way, what we have it. So basically, Shannon was a scientist. She, like introduced the concept of entropy in 1945, and through probability distribution. And the arguments is p. Arguments means the input values, like is p. So we will, like pass the probabilities of through the p. So this is the function over here. So this is, like built-in functions over there. Okay, and what we have it here, uh, there is, like calculation for this one, that how we normalization of the probability. So we normalize by this way. We, like call another function which is called the sum function of the p. So we sum all them, so which is equal to 1, right? And then we calculate the entropy. So as we know that an entropy has a formula, like p multiplied by np log of p, right? So this is the formula for that one, and by this way we get the entropy of that one. And then we have in return entropy. So this is the body of the function. Basically, here we define our own function. We derive it. So we did not use the ready-made function. We make our own function. Okay, and then what happened, then we use it. That how can you use it? For example, if I provide you the data, you have to put the data in this array, and this array will be assigned to the p, right? Then this p will be sent over here in this function. Okay, the function we already make it, right? Okay, this is already the ready-made functions we made it. And then when we call this function, what will happen? The value will be entered into this one. So you can make any variable, like entropy 1, entropy 2. Like you can make it, you can change the variable name as 1 and 2, or you can keep it as it is. Okay, so when I run this one, so the entropy is 2. So answer is 2. Let's try the another code. We have it, whether it's working or no. So we will see if it is working. That's fine. If it is not, then we will see that is there any error or something, or maybe the SciPy library we need to install it. So let's try this code, and the result. This code is shorter. The good thing in this code is that it's shorter, and we are using SciPy library over here, and we, like make it shorter as stats. Instead of the big name, we just like, give a nickname of the stats. And then the same, like, input we assign over here, and the input is like, is sent to a variable, our own variable. We devise it as a p. Okay, and then we use this one. So let's try this one. I hope this works. Okay, yeah. So there is no error, but the output is not showing over here. So might be there is some parameter missing, or maybe this library is not fully installed over. Yeah, yeah, it's coming. So it just took the time. Okay, so here the entropy is like, it is giving the entropy a little bit different with 1.386, right? So these two different codes, like, and we have it. So this is that how it works. This entropy. Similarly, you can find the code for Gini index. Let's see that if you could have, like, code for Gini index as well. Okay, so prompt. Yeah, this is called, the input is called prompt, right? So say code for Gini index in Python, right? So if I do this one, and I will see that how can I find the code for, so I can have some, like, yeah. So similarly, I have a code with the library of NumPy. So NumPy is in this one. We need to define our own library, because this library is small, it's weak, and this library doesn't have, like, much capabilities. So we have to define our own like library. Okay, in this one. So let me copy this one, and we see that how is the Gini index for the same input we have it. So for Gini one, we define library because this library is not strong, and by this way the formula is simpler, because here we need a square of that one, and then we return the Gini to this one. So this is just the construction. This is the main body of the construction of the function. Function means, like, some, like, a function we call it basically, and this one is the calling. We are calling it the function and Gini index, and let's see how it works. If there is any, yeah, so it's good. So we got like 0.75. This is our answer. Then how it works. Similarly, we have it like another one. Let's try the other code if we have. Yeah, sklearn. Yeah, this is another very strong library in Python. And if you try it, you will like it, this one. And it is stronger library and small code. The stronger the library, the code will be more shorter and small, and you don't need to define the code. So the NumPy is just for general numbers. So here you need to define a code. So we just got rid of this code designing, and we have ready-made code over here. We just need to pass our data in this array, and then we will find the Gini index. So let's see how it works. I think it's calculating. I think it might take time as it took in the previous. So we are receiving some errors. So most probably we need to, yeah, this sklearn. So here if you analyze this error, so sklearn library is not installable. So we need to import. We need to, like, install this library. So cannot import this one because from this library is not installed. So we need to install this library with the PIP, and in the next video, I will show you that how we can install this library, and this Gini index will work. So thank you very much for this time.